Okay, Assalamu alaikum, Bismillah ar-Rahman ar-Rahim. Thank you very much for joining this ventilator round. Feel free to ask a question anytime during the presentation. I don't mind if it is interactive, and hopefully we can get done in half an hour and then move to some questions and answers. So the discussion today is going to be about proportional pressure support. You're going to see two different names for this mode. And on dragger, let me put it up again. On dragger, it is called PPS, which stands for proportional pressure support. So if you look at the different modes that you have here, of course, you have your SIMV mode, and this is Evita XL. It's different a bit from in the newer dragger, but in the Evita XL, open the modes and go to more, and then you find here PPS. If you click on it, let's review the settings. What we see here is that we have number one, something called flow assist. And number two, we have volume assist. So we're going to explain those in details in my presentation. In addition to that, of course, you're going to set the FiO2 and you're going to set the PEEP. There are no other settings for this mode, and this is on dragger, and as I said, it is different on dragger than Bennett. On Bennett, it's called PAV+, which stands for proportional assist ventilation. So we're going to see the PPS first on dragger, and then we're going to present screenshot for PPS, for PAV, sorry. So let me admit others. As I said, I don't have assistants today, so I'm trying to admit everyone myself. So in principle, the flow assist, let me just get it run so we can, the flow assist will overcome the resistance. So if you have a patient with high resistance, you need to give them higher flow assist compared to patients with no higher resistance. And the volume assist is the pressure that's going to be used to overcome the elastance of the lungs. And the higher the elastance, the higher the pressure that you need, the higher the volume assist that you need to put on the machine. And then you can modify the flow assist and volume assist to obtain similar to a normal or spontaneous flow waveform. And spontaneous flow waveform is kind of sinusoid flow waveform. And that's what you see here. Look at how nicely the flow goes up and then gradually goes down. And this is achieved by balancing the flow assist, which is the initial rise in the pressure to overcome the airway resistance, and the volume assist that will determine the continued rise in the pressure to overcome the lung elastance. If you have a patient who has a very high elastance, you need to give more volume assist. If you have a patient who has airway obstruction and asthma, you need to give more of the flow assist. And always when you set this mode on the machine, you need to look at the work of breathing. And of course, this mode is only applied in patients who are able to trigger the ventilator. So it is only if the patient is able to spontaneously breathe on his own. What we're doing is we're taking information from the patient in terms of how much flow he wants to take, and we're giving him pressure support to assist his to assist him in getting that volume into the lungs. So in other words, it amplifies the pressure to help the patient breathe with less work of breathing. So this is on Drager. So let's go with the presentation. Of course, I'm going to explain all this in details so you can understand it fully. And the traditional mode of ventilations, such as the assist control mode of ventilations, the volume is constant, meaning that we fix the volume and then the pressure will be dependent on the airway resistance and the lung chest wall elastance. In pressure support or pressure control, the pressure is constant and then the volume is dependent on the patient's resistance and compliance. Now in proportional modes, and when we say proportional, we have mainly two different modes. We're going to be talking about the PAV or PBS today, which in this mode, the flow and volume both drive the ventilator. And this is the flow and volume of patient's efforts. And then we have the NAVA. It's another proportional mode, but the ventilator is driven by the electrical activity of the diaphragm, which is completely different than PAV or PBS. In NAVA, we need to insert a special catheter to be able to sense the diaphragm. However, in PAV, we are using the flow. So the flow sensor here gives me an idea about how much flow the patient is generating. So with inspiratory efforts of the patient, you decrease intrathoracic pressure and flow moves in. We can sense this flow here, and based on the flow that is generated, of course, flow over time is volume. So based on the flow, we would know what is the volume the patient is getting. So we have these two measurements that the patient is doing based on his work of breathing. Now, based on that, we determine how much we want to amplify the pressure for the flow, and this is the flow assist, and how much we want to amplify the pressure for the volume, and this is volume assist. And this way, the ventilator provides pressure which is proportional to instantaneous volume and flow that is generated by the patient. So we get information from the ventilator based on what the patient did, and then based on that, we deliver pressure to the patient to help him. So if you take a look on here, if this patient is spontaneously breathing, what happens is the patient needs to contract the respiratory muscles or inspiratory muscles to decrease the intrathoracic pressure. And the patient will generate flow, but the pressure that is decreased needs to overcome, number one, the airway resistance. And once we overcome the airway resistance, the flow goes into the alveoli. And at that time, we need to expand these alveoli. In order to expand the alveoli, we need to overcome the lungs and chest wall elastance. And then we generate a volume for the patient. So in proportional mode of ventilation, we get information about this pressure that is generated by patient, and then we link this pressure to the ventilator to deliver pressure support for him. If the patient is requiring too much pressure to overcome airway resistance or lung elastance, at that time, the machine will take over part of this work. So the machine will share the work of breathing with the patient in order to make it easier for the patient. So we get information from the pressure here, and we generate a pressure support for the patient. So the pressure support is variable from breath to breath based on how much the patient is generated for himself. And here, what you see is the equation of motion. And as you know, the equation of motion, there's a difference in the pressure on the left side. Airway pressure minus PEEP pressure. But the airway pressure will be generated, if the patient is on the ventilator, will be generated by the patient, which is the PMOS, which is the muscular pressure of the patient, plus whatever you give from the machine. That should be always equal to number one, the flow, and number two, the resistance. And then, and this is of course multiplication, flow multiplied by the resistance. And then you add to this the elastic work, the volume, how much volume we need to put into the lungs, and then the elastance of the lungs. So the left side here, a combination of the pressure, the ventilator pressure and the patient's pressure should always equal flow multiplied by resistance plus change in volume multiplied by elastance. Now, in traditional volume control, if you take this equation and look at volume control, CMV, assist control, whatever is named on your ventilator, what we have is independent variables. So you set the volume here. If you set the volume, so this variable is independent. So of course you set the volume by setting also the flow. There's no way you can set the volume without setting the flow. And then the pressure on the ventilator is dependent on the respiratory resistance and the respiratory system elastance. So if there's increase in the resistance, in order to deliver the same tidal volume, the pressure will go up. So that's why we say it is dependent. It is dependent on the resistance. Also, it is dependent on the elastance. If there's increase in the elastance, meaning patient goes into, for example, ARDS, the compliance is lower. Of course, the compliance is the reverse of the elastance. If the elastance is increased, at that time, the pressure would be higher. So this is dependent variable, which is dependent on the resistance and elastance. That's in volume control. Now in pressure control or pressure support, it's the other way around. We fix the ventilator pressure. So that is the independent variable. And the dependent variables would be the volume and the flow. So this is fixed, dependent on the resistance and elastance, the volume will be variable. And that's what you know about those traditional mode of ventilation. Now in proportional support, the flow and volume are dependent variables. And the ventilator is another dependent variable. Okay, how is that possible? Well, the pressure generated by the patient will dictate how much ventilator pressure we're going to give. So that pressure is dependent on how much the patient is breathing. If the patient is breathing too much, too heavily, is using accessory muscles, that's too much pressure. At that time, there will be a feedback to the ventilator to assist this patient, support this patient more, so the machine will utilize higher pressure in order to help the patient. Okay. And of course, if the patient is breathing too heavily, decreasing the intrathoracic pressure, he's going to generate more flow and more volume. And those are, of course, the flow and volume now are dependent on how much pressure the patient is generated. If the resistance is increased or the elastance is increased, the patient is going to utilize more pressure in order to generate the volume that he needs for himself. And at that time, the machine will sense that this patient is generating more pressure. And the way the machine senses this is by looking at the flow. Because if the patient is generating more pressure, it's going to generate more flow. Machine senses that, will give the patient more pressure to help decreasing the work of breathing for the patient. So in other words, we can say that pressure support proportional to instantaneous patient's effort. So it is simply pressure support mode. And the machine will give nothing but pressure support. However, the pressure support level is not fixed. It is variable. And how do we determine what is that level of pressure support? Is actually the patient is doing that. And the patient is the best person to know what he needs for himself. He needs more flow, he generates more pressure, he will get more pressure support. So what the ventilator does, it simply amplifies the inspiratory efforts of the patient. And the proportional pressure support follows spontaneous volume and flow. It is closed loop. You see variation in the pressure support from breath to breath. Now, when we say pressure support proportional to patient's effort, there are no sensors at the diaphragm like what we have in NAVA to measure the patient's efforts. However, the inhaled volume is a measure of how much the patient wants to breathe. And the inhaled speed of that air, which is the flow, is a measure of how fast the patient wants to breathe. This way, if we measure the flow, we will be able to give a volume assist and a flow assist. And let's take a look here and compare the volume assist on the left side here with pressure support in the middle and proportional support. And when we say that it depends on patient's effort, so let's change the patient's efforts and let's see how different it's going to be in each mode. So we have 3 colors here, as you see, which represents 3 levels of patient's efforts. And here we're measuring the PMOS, which is the pressure generated by the patient. In the orange solid line, you can see the pressure is at minimum. In the red dotted line, the patient generated higher pressure. The work of breathing for the patient increased. And in the blue dotted line, even increased further. And this is volume assist or volume control. So with changing in patient's intrathoracic generated pressure, with the orange color, you will see the pressure needed to get that volume in. However, if the patient started to breathe, what happens is that pressure goes down. So that's why you see in the red dotted, you can see that the pressure is pulled down. Why? Because the patient is helping the machine. So the machine will say this is not much needed actually, so let's go down on the pressure further. And this is, as you remember from the other sessions, this is an indication for us to know that the patient is, when you see this scalloping, this is an indication to know that the patient is actively participating in pulling this air inside the chest. And you can see further if the patient increases his effort further, you can see how the pressure is minimized here. So that's in volume control. Now let's see what happens in pressure control or pressure support. In pressure support, we fix the pressure. So no matter what, that pressure is fixed. Now with different level of patient's effort, you will see whether the patient breathes in this area here, in the red dotted line, or in the blue dotted line. You can see that the pressure does not change. It's the same pressure, and of course exhalation is determined by the patient and the ventilator. It's the flow essentially in pressure support. Okay, so let's compare this to proportional support. We have the same changes in the patient's efforts, and take a look on the pressure generated by the machine. The more the patient generates in terms of the pressure, the higher the pressure support that is given by the machine. So we give variable support for variable patient's efforts. If the patient's effort go down, the pressure support go down. And of course, in every breath, you need to determine how the breath is triggered, what does the machine do, and how the breath is ended. Or let's just say, how is inspiration triggered? What does the machine do during inspiration? And how the inspiration ended? And as we mentioned earlier, in this mode, the trigger is the patient. So this mode cannot be applied if the patient is paralyzed or is not able to breathe. The patient has to initiate all those breaths. And of course, you can determine what's the sensitivity that the machine will respond to. And especially in Bennett, you will see that you can determine the trigger level. Once you trigger the machine will give the pressure support level that is determined based on patient's efforts. It will be higher if patient's efforts higher. The more efforts the patient does, the more pressure support you're going to have. So what does the machine do? It will give pressure support. It will give a pressure. What's the level of that pressure? You don't determine that pressure. The machine determines that pressure. How does the machine determine that pressure? Based on how much the patient needed. If the patient generated higher flow, higher volume, the machine will give higher pressure support for the next breath. So you will see the pressure support is variable from breath to breath based on what does the patient do. And how is the inspiration ended, which is the cycling, it is determined by the patient. When the patient ends his inspiratory effort, at that time, the machine cycles and pressure goes down to the baseline variable. And in Bennett, you can determine the expiratory sensitivity. You can say once you reach 3 liters per minute of the flow, just release that pressure and go to the baseline variable. So this is just to show you that in pressure support mode of ventilation, this is a traditional support that you know. You can easily over-assist the patient. And look at this example here. We have the diaphragmatic pressure here, and you have the esophageal pressure. And you can see that the patient's efforts were only in the beginning of the breath. However, the pressure support was given to the patient and remained at the same level for the whole duration, despite the fact that the patient is not doing any more efforts. In proportional mode of ventilation, the machine will change that pressure support to accommodate patient's efforts. And of course, if the patient is not making much of the effort at that time, this mode is not suitable for that patient. So this is only for those patients who are able to generate their own work of breathing. But we're trying to help them not to exhaust themselves by helping them when they are able to do it. So we minimize the work of breathing. But if the patient is not able to breathe at all, at that time, this mode is not appropriate. So far we heard about this volume assist, and we heard about the flow assist. And how does it work? Well, it is pressure support that is determined based on the inhaled volume. And you can see here, we give 1 centimeter of water for 0.1. We give 5 for 0.5, 10 for 1 liter, and 15 for 1.5 liter. So if we set it at 10, at that time, the machine will give 10 centimeter of pressure support for the volume of 1 liter. If that liter goes down 0.5, it would be 5. And what you see here is, this is the volume of the patient. As you see, the pressure that is given to the patient, and this is based on the volume, the inhaled volume. That's why you see the pressure is increased at the end of the breath, and it is at the maximum at this point here. Now, the patient generated less volume. You can see the pressure is less. Here is generated higher volume, the pressure is higher. Now, in some of those machines, this happens within the breath, and the measurements are happening every 8 milliseconds, up to 200 measurements per inspiration. And that's why you see instantaneous changes in the pressure with the volume. Patient pulls in more volume, he gets more pressure. Pulls in less volume, he gets less pressure. Now, if we change this to 20 centimeter per liter, you can see that for the same volume the patient is pulling, it will be more pressure given to the patient. So this is how you modify the pressure for the patient based on his own efforts. Okay, and you determine how much you want to help the patient. Now, the machine is doing more work here for the patient. And when you go down to 10, that means that the machine is doing less work for the patient. So what you see here, I have set the ventilator on flow assist of 0 and volume assist of 10. Of course, the PEEP is 5, and we have FiO2 here of 36%. So you can see that the pressure goes up gradually with increasing volume into the chest, and it's amplified with the factor of 10. And the flow goes up gradually. You can see the flow is the highest at the end of the breath, and then goes down as the patient started to decrease his inspiratory efforts. It will be cycled into expiration once the flow reaches a certain value that is set on the machine. Now, flow assist is for resistance. I just separated volume assist from flow assist so you can understand those individually, and then we can combine them together. So what we're doing here is we're setting the pressure support, but now it is proportional to the inhaled flow, which is liter per second. So for example, we set it at 5 centimeter if the flow is 0.5 liter per second, 10 if the flow is 1 liter per second. And then the pressure will go up gradually to that level based on patient's efforts at the initiation of the breath. And you can see here how I set the flow assist at 8, and now volume assist at 0, just to see the difference. And look at the pressure. The pressure goes up initially with the increased patient's effort, and then goes down gradually because I don't have any volume assist here. And the flow, since the pressure is high at the initiation of the breath, the flow goes up to the highest level and then it goes down gradually. So this way you can see that what we set is a flow assist to overcome the airway resistance. And of course, we always set ATC, which is automatic tube compensation, to compensate, which is similar to pressure support. It depends on the size of the ET tube that you have. And we usually set it at 50% with PPS. So we have that pressure, and then we add to it another pressure that is coming from the flow that the patient is able to generate. And then we add another pressure that is dependent on the volume that the patient is generating. So you get the ATC, you get the pressure for the flow assist, and you get the pressure for the volume assist. This is PPS. Compared to pressure support ventilation, it's the same pressure for all. We just set a pressure of 10 centimeter, and that will be given from the initiation of the breath till the end of the breath. And this is the separation. This is when we have only volume assist, and you saw this is the pressure that goes up like this, and it is the highest at the end of the breath. This is the flow assist alone. The pressure goes up at the initiation of the breath and then goes down. And then you combine this together, you have flow and volume, you get this shape of the pressure, which is similar to the fish fin. And that's what we want to see, that the pressure goes up gradually and reaches the highest at the end of the breath. And of course, all this pressure is on top of the PEEP. That will give you altogether the volume assist, the flow assist with the PEEP will give you the airway pressure. So let's take a look on this example here. So just to make it easy for you, I put the diaphragmatic electric activity of the diaphragm, electrical activity of the diaphragm. So you can see here how the diaphragm is actually changing in its activities. So just to relate this to the pressure that is generated by the machine. Okay. Of course, if you have contraction of the diaphragm, you're going to generate flow, and you see that here. This flow is generated, feedback to the machine, patient is generating flow, let's give him pressure. This is the initial pressure that is increased because of the patient's efforts and the flow. Now patient is generating volume, and because of our volume assist, we're going to give more pressure. You can see that the pressure level is changed here. It's increasing rather than is constant. It is within the breath. It's not breath to breath only. It is both within the breath and breath to breath also. You can see how the pressure is changing within the breath here. It's all because of the flow assist that we have initially and the volume assist that we have at the end of the inspiration. Similarly, this is very similar to this one. Look at this more even electrical activity of the diaphragm, giving you more even rise in the pressure. Here, minimal activity caused less pressure support for the patient. Higher activity here caused higher support. Take a look on this one. Very high activity generated high pressure. You can see the pressure that is given to the patient. So what are the initial ventilator settings? If you want to set this machine, what do? We recommend that you set the flow assist at around 8 centimeters of water, between 5 to 10. And the volume assist around 4 to 5 centimeters of water per liter, of course. And then you observe the respiratory rate and the tidal volume. And if you take a look on the respiratory rate and tidal volume, that is your rapid shallow breathing index. Divide the respiratory rate over the tidal volume. That is your RESP. So the rapid shallow breathing index. This is an indication to you whether it's too much assist or too little assist. It's an indirect way to know the work of breathing for the patient. And then you increase the volume assist in steps of 2 to 3 centimeters each time. Of course, you need to set the alarms which for the pressures and volume as appropriate for the clinical condition of the patient. In general, patients with COPD would need higher flow assist, and most of the time those patients that would need either no or very low volume assist. On the other side, patients with decreased lung compliance would need higher volume assist and minimal flow assist. We're going to see that also we're going to monitor not only the RESP, but also the P 0.1, which is the pressure decrease during the first 100 milliseconds of the inspiration. This will give you an idea about the respiratory drive of the patient, and then you can increase or decrease your settings for that specific patient. And always you need to set the alarms appropriately. You need to set the minute ventilation, the tidal volume, the pressure alarm. So you need to make sure they don't exceed if the patient has pneumonia, ARDS, you want to make sure that the pressure doesn't go up higher than protective lung strategy. You want to be alarmed also when the rate goes above specific number. Similarly, you need to have an apnea. If the patient goes apneic, you have the backup mode and the ventilator will change to that. So those are the main settings. As you see here, only FiO2, volume assist, flow assist, and the PEEP. Now, as I mentioned, you start usually with a flow assist of 8 centimeters, and then assess the patient's flow demands and make appropriate changes. If you see that you're increasing the flow too much, at that time, go down a little bit on the flow assist. The volume assist, you start at 4 and assess the tidal volume, and you need to see that the waveform, the flow waveform, is close as much as possible to a sine flow waveform. If it is too wide, then you're given too much volume assist, you need to go down. And usually, as I said, the automatic tube compensation is usually set at 50%. PEEP is taken from the same level that you used on previous mode. And of course, you need to have apnea ventilation on just in case your patient goes apneic, and you have a backup plan for that, or backup mode. Also, you need to have alarm settings for high tidal volume and apnea. What you're going to monitor, number one, you need to see the flow waveform. As I said, you always would like to simulate normal breathing with a sine flow wave or sinusoidal. And then you look at the RSPI, rapid shallow breathing index. If it is too high, you need to decrease the PPS levels. If it is too low, you need to increase the PPS level. And you need to look at the pressure generated in the first 100 milliseconds, which is P01, 0.1. You need to maintain that between 1 to 4. So if your patient is in range of 6 or 7, that means you need to increase the volume assist so he can decrease his work of breathing. If it is lower than 1, you need to decrease the assist, whether it's volume or flow, in order to increase the work of breathing for the patient. So as you see with this mode, we let the patient drive the ventilator, and we maintained efforts of the diaphragm, and we still have our limitations in terms of ventilator protective strategy in patients with ARDS. So I'm sorry, the resolution is not that great for these slides, but those are good examples of PPS on Drager. This is perfect actually. Let's just take a look here. This is the flow and this is the pressure. You can see here a flow assist of 8 and volume assist of 8. We can see that the pressure over time, it's like the fish fin that we would like, and the flow is very close to sine wave, and the volume that is generated with this is 350. Look at the RSPI is 56. We like to see it between 40 to 60 for RSPI. Anything higher than this indicates that you may need to increase the support for the patient. Anything less than this, you may need to consider decreasing the support for the patient. When you see a wave like this for the flow, you can see that it goes very fast. This is similar to square wave, and this is an indication that you're giving too much flow assist for the patient, so you need to go down. And this is an example of this, where you see that the flow goes up very fast, and this is an indication that you're giving too much flow assist. Now, at the same time, take a look on the volume that is generated, and you see that it's only 172, meaning that you're not giving enough volume assist for the patient. So if you see something like this, you need to go down on the flow assist and go up on the volume assist. So let's take a look on this patient here. As I said, the things that we monitor, number one, we would like to see a flow waveform that is similar to spontaneous breathing, which is sine wave or sinusoidal. And you can see that we're going up on the flow gradually. Here it's cut off at the end of the breath. Now the pressure is similar to the fish fin. However, if you take a look on the volume, it's 935. And if you take a look on the rapid shallow breathing index, it is 14. So that indicates that we're giving the patient too much volume assist, and you need to go down on the volume assist for the patient. To decrease the volume for him, increase the rapid shallow breathing index a bit. On the other hand, if you take a look on this patient here, you will see that the tidal volume is 378, but RSPI is on the higher side. This patient would need to have more of volume assist. He's on a flow assist of 2 and volume assist 7.6. So you would need to go up higher on the volume assist for this patient. This patient, you can see volume of 577. The rate is 15. RSPI is high. I don't see it here, but this is too much volume assist for the patient. And you can see here it's got flow assist of 10 or 11 and volume assist of 20. You need to decrease the volume assist and probably also the flow assist. You can see how fast this flow is going up here with the flow assist. In this patient, it seems okay actually, 574 on the high side a little bit, rapid shallow breathing index 26, sine wave very nice here. Maybe we can decrease the volume assist a little bit because of the larger tidal volume for the patient. Now this patient is clearly having what we call overcompensation. Too much tidal volume he's getting results into, and this is the normal reflex, if we give too much volume, you may end up in apnea, and that's what's happening here. So overcompensation resulting into apnea. So you need to decrease the volume assist for the patient. And this patient, with tidal volume of 860. We can see very nice fish fin waveform for the pressure. You can see very nice sine wave here. You can start weaning the patient. Go down gradually on both volume assist and flow assist. Each time 2 to 3 units per time. This is 274, RSPI 77. Clearly, the patient can benefit from higher volume assist. And that patient was given higher volume assist. Take a look on the previous screen, 274. RSPI is 77. Now we have higher tidal volume. We increased the volume assist from 8 to 15, and that resulted into better volume, better RSPI. Look at how nice the flow waveform is and the pressure increase. Notice the gradual increase in the pressure. That's what you want to see. This is again another overcompensation that results into apnea, and you don't want to have this with your patient. You need to decrease the volume assist for him. This patient looks great actually with RSPI 31 and the tidal volume 523. Look how nice the waves are. You need to start weaning this patient. Go gradually, and he's very close to weaning. This is flow assist of 6 and volume assist of 5. You may change to CPAV and see how does the patient do and get him extubated. So the weaning is very simple. Those patients are already on pressure support trials, and the pressure support is variable. Just decrease the volume assist and flow assist at 2 to 3 units per time. And then you transition to CPAP, and don't forget to change the automatic tube compensation to 100%. We set it at 50% with this mode. When the patient meets the criteria for SPT, he can be extubated. Now, you may run into a phenomena that is not well explained. There's a lot of work been done by Dr. Yunus in Greece, and it's actually the Dr. Yunus is the one who started the implementation of this mode, and the idea is his idea, and most of the literature is done at his institution. And in fact, I met him once in Riyadh. He came and gave a very nice talk about PBS. And this phenomena is runaway phenomena. So what you see here, the diaphragmatic electric activity of the diaphragm. So this is start of the activity. This is end of the activity. As you see, correlates very nicely with the pressure given by the machine. This is variable pressure, as you see, goes up gradually. Now here we have more activity of the diaphragm. Take a look on the pressure. See how we, for higher activity of the diaphragm, we're given more pressure. So the pressure is changing for more flow that is generated by the patient. However, what you see here is the end of the electric activity of the diaphragm. And if you get a column up here, you will see that the pressure is continued by the ventilator. That's why we call it runaway phenomena. And as I said, it's not clearly understood, but it's related to the technology is inherited with this mode, and it is because of the delay in the response of the ventilator to the cease of the electrical activities. So in summary, just you need to put in your mind that you have the breath or the inspiration. The initiation of it is airway resistance. You increase that by flow assist. And the second part of it is when the flow goes inside the lungs, and you increase that by volume assist. Multiple studies. The purpose of this presentation is not to show you whether this mode is better than the others or not, but I thought people may question that. And you can see that this is a meta-analysis in favor of proportional pressure support modes in terms of weaning faster from the ventilator and shortening the time on the ventilator. So those patients who were on PPS had a higher rate of weaning success, lower reintubation rate also, and shorter mechanical ventilation duration. Mortality was the same with others. And let me see, I think, yeah, I'm going to talk a bit about predetermined Bennett, which is different. So it's the same formula that you need to have in mind. Again, on the left side, this is the equation of motion. On the left side, we have the ventilator pressure that should equal to resistance multiplied by flow plus elastance multiplied by volume. Now, in predetermined Bennett, we decide how much, what is the percentage that the machine needs to, what's the percentage of the work of breathing that the machine needs to take over. You can set this from 0 to 95%. You always want the patient to do some work. So, and let me just show you the screen so you can understand the settings. Okay. So here, this is the screen on the newer Bennett, I believe. Of course, you can utilize this as invasive mode for the patient. The PPS can be used invasively or non-invasively. Now, the problem with the non-invasive ventilation is the leak, because if you have a leak in the system, you're going to be disrupting those numbers. So I think as I remember correctly, I don't work with the Bennett, but I think it's not recommended to be used in non-intubated patients. I'm not sure about the newer ones, but I need to review that. Now, you can see here invasive, and this is a spontaneous mode. And what type of spontaneous breath that we're going to use? We're going to use proportional assist ventilation plus. Okay. And all what you're going to set is the percentage of that work of breathing that the machine will take over. And we're saying here, take over 70% of the work of breathing. If you take a look on the other settings here, you can see this is the flow sensitivity. This is the trigger. The patient needs to initiate 3 liters per minute in order for the machine to be triggered. FiO2 level, this is the peak level. This is an alarm in the system. Cannot go in the pressure higher than the peak level. Now here, this is the cycling sensitivity. The flow, once it gets to 3 liters per minute, at that time the pressure is released. And this is the PEEP, and this is just an alarm for the tidal volume. So what you see here is actually you're setting when you want to trigger the ventilator and when you cycle. And the pressure is adjusted by the machine, whatever it takes to take over 70% of the work of breathing. And the machine will calculate the pressure based on multiple or every 4 to 7 or 8 breaths. It will place a hold and measure the peak pressure and the plateau pressure. And once we measure the peak and plateau, we'll know what it takes in terms of the pressure to deliver the volume for the patient. So the machine will be able to give 70% of that work, 50%, whatever you set it out. And you can see this bar here, which gives you the work of breathing. And if you set it at 70%, you can see that work of breathing goes from 0 to 2 joule per liter. And the patient, we like our patient to be in this area here, or the work of breathing of the patient. And this is normal work of breath. We do not generate more than 0.7 joules per liter. Okay, so you want your patient's work of breath to be here in this area here. Okay, but if this is what it takes actually to ventilate the patient, everything else should be done by the machine. So you can adjust the work of breathing. And when you adjust the work of breathing, if you go up to 90%, that means this is going to move this way, and you're going to take over more of the work of breathing for the patient. This is an example of the older Bennett. I think this is the 840. And you can see here that we set the percentage of support at 50%. So you don't set any flow assist or volume assist in this one. You only set the percentage of support that you want the machine to take over. And the machine will calculate the work of breathing the patient is requiring to deliver the volume that is generated by the patient. And then it will divide the work between the patient and the machine based on this percentage that you set on the machine. You can see here also this is the trigger, and this is the cycling FiO2 and PEEP. And this patient, as you see here, this is the total work of breathing, okay, very close to where we want it. But since we set it at 50%, you can see that the patient is doing 50% of the work, close to 0.35, and the remaining is done by the machine. And this is the newer machine. I think this is a predetermined Bennett. As I said, I don't work with it, but this is exactly the same. This is 70% of the work that needs to be done by the machine. And those are the poses that I was telling you about. Every few breaths, it will be a pause. And the purpose of this is to measure the peak pressure and the plateau pressure. And this way, we would know exactly what is, this is the flow ash I was pointing to it. This is the pressure, peak pressure, and the plateau pressure. In this one, peak pressure and plateau pressure, you can see the plateau here is higher than the peak. We need to talk about that in a separate talk, but I think I explained this in one of my asynchrony talks. And with this, I would like to end and see if you have any questions. I would be more than happy to answer. So you can send your questions in the chat section, or you can raise your hand. Just unmute yourself and talk if you have a question. Go ahead, Dr. Ala.
Thank you so much, Dr. Mazen. It is amazing lecture, but for me, this is the first time I heard pressure support and PSV. So I need more time. Another, if you have a time, of course, to repeat this lecture again.
Well, yeah, number one is going to be uploaded to the website, and you can access it. It's all available to you, so you can watch this again and again. But certainly, with our discussions with the ventilator on the ventilator rounds, we're going to discuss it in different way. You know, my aim of presenting this mode is not necessarily that you utilize it at the bedside. We always recommend that you only use the mode that you're comfortable and you're able to understand fully. I don't recommend that you start a mode that you do not understand. But the purpose of this is to expand your knowledge about how are those newer modes working, and in case we have literature to support that those modes are functioning better than the traditional mode, at that time we need to transition towards those kind of modes. By the way, the asynchrony index, there's another study that I did not put. The asynchrony index is much better with PPS compared to conventional modes of ventilation. And it is so nice actually to understand mechanical ventilation, and you can see how much value we have out of the equation of motion. Everything is based on the equation of motion. Go ahead, Faisal.
Thank you, sir, for this lecture. I have two questions. The first question, how the how to assist or how to monitor the flow assistant. You said about the volume assistant, how to monitor, and how to monitor the flow assistant. This is the first question. The second question: how the ventilator terminate the breath after I mean, how to cycle it, how the ventilator knows to terminate the breath in the PPS.
Yeah, very good, Faisal. Thank you. So first question, how to monitor the flow assist is the rise in the flow. If you have a very high rise in the flow, you don't want that. You want to have a smooth increase in the flow, similar to the spontaneous breath. So again, this mode is very close to our spontaneous breath, and that's the purpose of it. It should actually be triggered by the patient, and then we should go up slowly in the flow, similar to the way we breathe. We go increase the flow slowly, and that's what you want to see. So if you're increasing the flow very fast, I give some examples of this, you need to decrease the flow assist. Okay. And then the inspiration is ended based on the patient's flow. And as I said in the Bennett, if it gets, you can set that at 3 liters per minute, meaning that the patient needs to generate 3 liters per minute initially, if the trigger sensitivity is set at 3 liters per minute. And then the breath is given with the pressure support that is changing. And then once the flow reaches again 3 liters per minute, at that time the pressure goes down. So it is exactly similar to pressure support. Pressure support is triggered by the patient based on the pressure or the flow. By the way, the Bennett, you can decide you want the pressure or the flow. I think, let me just see if I see it here. Maybe yes, maybe no, I don't see it. But yes, you can decide whether you want the pressure or the flow to trigger. Very similar to pressure support. The only difference is who decides about the pressure level. In pressure support, it is you. In PPS or PAV plus, it is a patient. Okay, the patient decides how much pressure support is going to be. Okay. In PPS, in PAV, it depends on the percentage that you set also on the in terms of the percentage of that support. I see in the chat section here, Paulo asked a question, is PAV plus a modality we can use in patients suffering from COPD, or is it better to avoid it if we have reason to? Yes, thank you very much. Well, Paulo, your questions are always very deep. In fact, actually, this is one of the problem with this mode. If you have auto PEEP, the mode cannot function very appropriately. However, let me just show you something that there's a slide that I did not want to show, this one. Okay. So when you build an auto PEEP, it makes it more difficult for the patient to generate a flow. So in other words, you may not be able to respond to the patient's efforts. And this is where the problem of this mode. Again, this mode is triggered based on the patient's flow. So the patient needs to trigger the flow initially. If he's unable to trigger the flow, if he's not able to generate enough flow to trigger because of the auto beep, at that time you're not going to trigger the ventilator. So this is where the problem with auto beep exists. You need to make sure that when you see the patient is able to trigger the ventilator adequately and able to generate enough volume to ventilate and oxygenate. Now, this doesn't mean that the patient with COPD should not be placed on on PAV plus. No, you can use it on PAV on patient with COPD. However, you need to pay attention. If you have a high auto beep, you may not be able to trigger the ventilator in those circumstances. Any other questions? Let's just see. So what is the difference between PPS and volume support? Okay, so volume support is also a mode that changes the pressure support for the volume that you set on the machine. The physician sets that volume on the machine and says that I need 400 tidal volume. The machine will change the pressure support up and down to achieve that 400 tidal volume. If the patient starts to breathe and contribute, the pressure goes down. If the patient decreases his contribution, pressure goes up. The target is always 400. Okay. So think about it. Now you see the difference. Well, if the patient increases his inspiratory efforts, the pressure support may go down to 0 with volume support. If the patient is able to breathe and deliver that volume for himself, the machine will give him nothing. This is volume support. Now in PPS, who decides about the volume? The patient, not the clinician. The patient decides that he wants that volume of 400, for example, and then he works for that volume. If the patient works too much for the volume, the machine will help him. It's the other way around with volume support. So I hope it is clear, Reem. Thank you very much for the question. And Ala, do you have another question? You have your hand is raised still.
No, thank you so much. This is
Okay.
the first one.
Excellent. So if there are no more questions, thank you very much for your attendance. As I said, it's going to be uploaded to the website. Just go to the education and it will be under advanced mechanical ventilation. Thank you very much and see you next time.